Hello friends, welcome to this session on constructions. In previous session, we learned how to construct the bisector of a given angle and also gave proof that the construction we made is right. In this session, we will learn to construct a perpendicular bisector of a line segment and will prove that the construction is correct. Let's assume we have to construct perpendicular bisector of PQ. So let's start the construction. The steps for this construction are as follows. With the help of scale and pencil, draw a line segment. Let's name this line segment as PQ. Now taking a measurement of more than half of the line PQ, place the pointed end of the compass on P and draw an arc above and below PQ. Now without changing the measurement, place same pointed point on Q and draw arc below and above PQ in such a way that they will intersect previously drawn arc. Note that measurements of radius from point P and Q have not changed. Let's name the intersecting point X and Y respectively, and with the help of scale, join SY. And let's name the intersection point of PQ and XY as O. The point where the line XY intersects the line PQ will divide the line segment PQ into two equal parts, and XY will also be perpendicular to the PQ. You can check the measurement of PO and OQ with the help of the scale, whether it is equal or not. Also, with the help of the protractor, we can also check whether the angle formed is 90 degrees or not. So in this way, we constructed a perpendicular bisector of a line segment. Let's prove it mathematically as well. Now we will prove that PO is equal to OQ and angle XOP is equal to angle XOQ is equal to 90 degrees. If we prove the triangles XOP and XOQ congruent, and since the corresponding parts of congruent triangles are equal, therefore we can say that sides and angles are equal, and it will be easy to prove that PO is equal to QO and angle XOP is equal to angle XOQ is equal to 90 degrees. For that, we will first take triangle XPY and triangle XQY by joining PX, PY, QX and QY. Now in triangle XPY and XQY, side XP is equal to side XQ because these are arcs of equal radius. Similarly, side PY is equal to side QY because these are arcs of equal radius, and side XY is equal to side XY, common side. That is, triangle XPY and triangle XQY are congruent by side-side congruency rule. Therefore, angle PXY or say angle QXY will be equal to QXY or say angle QXO because the corresponding parts of congruent triangles are equal. Let's this be equation 1. Now let's take triangle PXO and triangle QXO, as we know that side PX is equal to side QX because these are arcs of equal radius. Angle PXO is equal to angle QXO by equation 1, and side XO is common side. Therefore, triangle PXO and triangle QXO will be congruent by side congruency rule. And therefore, side PO is equal to side QO. The corresponding parts of congruent triangles are equal. That is, point O bisects the line segment PQ. We have proved a part that PQ is bisected by XY. Now it is yet to be proved that the line XY is perpendicular to the line segment PQ, so that it can be proved that it is perpendicular bisector of PQ. Here angle XOP is equal to angle XOQ because corresponding parts of congruent triangles are equal. Let this be equation 2. And angle XOP plus angle XOQ is equal to 180 degrees because these angles form a linear pair. Let this be equation 3. Now, by equation 2 and equation 3, we can say that angle XOP is equal to angle XOQ. Therefore, both angles will be 90 degrees. Angle XOP is equal to angle XOQ is equal to 90 degrees. That is, XY is perpendicular to PQ. Friends, that's it for today's session. Today we learned to construct a perpendicular bisector of a line segment and also learned to prove it. Meet you in the next session with some questions based on the same. Thank you.